First question is how to draw pressure, volume and temperature entropy diagram for Rankine cycle with superheated steam, which is thermodynamic vapor cycle. Second question, solve one problem on Rankine cycle with superheated steam by using steam table. Let us understand how to draw pressure, volume and temperature entropy diagram for Rankine cycle with superheated steam. As this cycle is thermodynamic vapor cycle, steam is used as a working substance. If we observe this diagram, here is boiler, turbine, condenser and hot well are the four main components where the steam is passing through each component when the different processes are taking place. Now we will consider the initial condition of the working substance. We will consider 1 kilogram of saturated water is entering inside the boiler at pressure P1, volume V1 and temperature T1. Now we will show this initial condition with point 1. So at the entrance of the boiler I will show here point 1. And here will be pressure P1, then volume V1, and if we observe this temperature entropy diagram, here is the saturated liquid line. Now, what is the phase of working substance? That is saturated water. That means it is in liquid phase. So we have to show point 1 on this saturated liquid line. So I will show here point 1. Corresponding temperature will be T1 and entropy S1. Now we will move for the different processes. So process 1 to 2 is the heat addition at constant temperature and constant pressure. Now if we observe the process 1 to 2 is taking place inside this boiler and it is taking place with constant pressure as well as constant temperature. Now what is the condition? So condition is that the Rankine cycle with superheated steam. So when this heat addition process is taking place, then the saturated water is getting converted into superheated steam. So I will show here point 2. I will show arrow also. Now what is the effect of heat addition on other parameters, that is volume and entropy? So its volume is getting increased as well as entropy is also getting increased. Now we will show here the process 1 to 2. So with pressure remains constant, here will be point 2, here will be volume P2. Then what about this temperature and entropy? So we have to show constant temperature but only up to this saturated water is getting converted into dry saturated steam. And after that, when we continue to addition of heat inside the boiler, then this dry saturated steam is getting converted into superheated steam. And during this heat addition, the temperature of this dry saturated steam is getting increased as well as entropy is also getting increased. And we have to show this. So I will show here this point 1. I have to draw with temperature constant. And here will be point 2. So at this point 2, if we observe this 1 and 2 having same temperature, because when we add the heat, then this heat is used to convert the phase, that is saturated water is getting converted into saturated steam or dry saturated steam. This is known as the latent heat. So heat absorbed during this process is known as the latent heat. Now when this dry saturated steam is again heated, then what will happen? Its temperature will be getting increased as well as its entropy will also getting increased. So we have to show this increase in temperature as well as increase in entropy. So here will be our new point. And if I extend or I will show the temperature at this point, then here will be T superheated. And here this point, new point, I will show 2 dash. Then here I will say that T1 is equal to T2. So this is the whole process. So here is this entropy will be known as S superheated. Entropy at this point 2 dash. So I will say that 2 superheated also, because this is the point 2 that is at superheated state. So entropy at this point is known as S superheated. Here instead of 2 dash I will say 2 superheated, then here related to this temperature will be T superheated and entropy S superheated. Now what is the amount of heat absorbed? So how to calculate this? So amount of heat absorbed, that is nothing but H superheated during this whole process from 1 to 2 and 2 to 2 superheated. So how to calculate this? So we will say here that will be H2. So for H2, if we observe, when the saturated water is getting converted into dry saturated steam, then here what is the amount of heat absorbed? That is nothing but Hg2, because here this enthalpy at this point 2, because point 2 on this saturated vapor. So we will say that how to measure the enthalpy at this point 2, that is we will show with the help of Hg, and at point 2 I will say Hg2. So I will write here Hg2. Then what is the enthalpy at point 1? That is HF1. Then after this point 2 it is getting superheated. So how to measure the amount of heat absorbed here? So for that we have to use the specific heat of superheated steam, that is Cp. And then we have to take the difference in between the temperatures. So here at point 2 superheated temperature is T superheated minus temperature at point 2, that is T2. So I will write the formula. So H superheated is equal to this Hg2, enthalpy at point 2, that is this Hg2, plus we have to take this specific heat of superheated steam, that is Cp, multiplied by, we have to take the difference in between these two temperatures, that is T superheated minus temperature at point 2, that is T2. So this is the formula that we have to take. Now if we refer the steam table, then in steam table there is the table for the superheated steam. So here specific enthalpy of superheated steam is given. Now this process of heat addition is taking place at constant pressure. So when this pressure is known as well as the T superheated, that is the temperature is known, then we can directly find out the value of this H superheated, that is the for the specific enthalpy. So here the table is given on this vertical column. Here absolute pressure in bar is given. On this horizontal line the temperature is given. So these temperatures are known as these temperatures are given, that is for the superheated steam. So we have to take this pressure and related temperature, and here we can find out the specific enthalpy. Then we will move for the next process. So next process is isentropic expansion. So this superheated steam is there, it is entering inside this turbine, and here isentropic expansion is taking place. That is process 2 to 3 is taking place inside this turbine. So this process is isentropic, that means entropy will remain constant. So whenever the entropy remains constant, that means no any heat addition and no any heat rejection process is taking place. Now we have to show this process 2 to 3. So entropy remain constant. So what is the effect of this expansion on other parameters? So when the expansion process is taking place, pressure is getting decreased, volume is getting increased, and as pressure getting decreased, temperature is also getting decreased. So we have to show this process 2 to 3. So I will show here 2 to 3. Here will be point 3. So pressure P3 is there. Pressure is getting decreased. Then here volume is getting increased. So here will be V3. So here P1 is equal to P2. We have to take this. Now we have to take entropy constant and temperature, decrease in temperature. So I will show here. So here is the 0.3. So S superheated is equal to S3 because entropy will remain constant. Now we will move for the next, that is process 3 to 4. So process 3 to 4 is taking place inside this condenser where the heat rejected at constant temperature and pressure. That means this is the cooling process. Now remember, if we observe the condition of the working substance at point 3, that is it is the wet steam, that is some water particles are there, and when this cooling process is taking place, this wet steam is getting converted into saturated water. So we have to show this point 4 on this saturated liquid line. Now we will show this, but this process is at constant temperature and constant pressure. So we have to show pressure constant as well as temperature constant. Now what is the effect of cooling on the volume and entropy? So volume is getting decreased and entropy is also getting decreased. So we will show here. Now we will show this point 4 on the saturated liquid line. We will show arrow also. Here P3 is equal to P4. Here will be 0.4. Then here entropy is 4 and here temperature T3 equal to T4. Now how to calculate the heat rejected? Now for that, this cooling process is taking place in between this point 3 and point 4. So enthalpy at point 3. So for wet steam, enthalpy is H3. Now how we can define this H3 with dryness fraction X3? So we know the formula, H3 is equal to HF3 plus X3 HFG3. And what is the enthalpy at point 4? So point 4 is on the saturated liquid line. So we will say here this enthalpy is HF4. Now we have to take the heat rejected. So we will take here this H3, that is HF3 plus X3 HFG3. I will write HF3 plus X3 HFG3 minus, we will take this enthalpy HF4. Now if we observe this point 3 and point 4 is at both points are at constant temperature. So at this temperature and both are at constant pressure also. So if we refer this steam table, that at particular pressure this value HF3 and HF4 are same. So because this process is taking place at constant pressure, so from this steam table this HF3 is equal to HF4. So it is getting cancelled because HF4 is having minus sign. So what is the answer? Heat rejected is equal to X3 HFG3. So this is the formula that we have to use to calculate the heat rejected. Then we will move for the next process, that is the warming at constant volume. So again process 4 to 1, here is the hot well for where the warming process is taking place at constant volume. So we have to keep the volume constant, and this process is process 4 to 1. So I will show arrow here for the process 4 to 1. And on the pressure volume diagram, when the heat addition or warming process is there, pressure is getting increased, temperature is also getting increased, and entropy is also increased. Now here we have to keep volume constant. So we have to draw here straight vertical line. So here V1 is equal to V4. So this 4 to 1 process is there. Now how to show this process on temperature entropy diagram? Now at point 4, saturated liquid phase or saturated water is there. So when we add the heat, then this addition of heat is sensible heat. That is, the phase of the working substance remain constant. So we have to show process 4 to 1 along this saturated liquid line. So I will complete this. So here is S4 and here is S1. Now how to calculate the heat absorbed? So again we have to take the difference in between these enthalpies. So if we observe HF1 minus HF4, how we can take the difference? That is the enthalpy at point 1 minus enthalpy at point 4. So HF1 minus HF4. Now if we observe this diagram, this point 1 and 2, that is process 1 to 2 is taking place at constant pressure, and process 3 to 4 is also taking place at constant pressure. So again if we observe the steam table, then the value of HF2 is equal to HF1. So instead of HF1 I will write here HF2, and HF4 is equal to HF3. So I will write here HF3. So we can use this formula, heat absorbed is equal to HF2 minus HF3. We will solve one problem. A steam turbine receives steam at 15 bar and 350 degrees Celsius and exhausts to the condenser at 0.06 bar. Determine the thermal efficiency of ideal Rankine cycle operating between these two limits. Let us first understand what is the given data. It is given that the turbine receives steam at a pressure of 15 bar and temperature 350 degrees Celsius. Now if we observe, after boiler, here is the turbine and turbine receives steam at point 2. So what is the pressure at point 2? So it is given 15 bar. But this process 1 to 2 is taking place at constant pressure. So we will say that P1 is equal to P2 is equal to 15 bar. And temperature is also given, that is the 350 degrees Celsius. So we will take here the temperature at point 2, that is T2 is equal to 350 degrees Celsius. And steam exhaust at pressure of 0.06 bar. So when the pressure decreases in the turbine, then at point 3 pressure is 0.06 bar, but process 3 to 4 is taking place at constant pressure. So we will say that P3 is equal to P4 is equal to 0.06 bar. Now here if we observe this question, no word superheated is used, but this is the case of superheated steam. So how we can find out this? So for that, if we observe the first sentence, then pressure is 15 bar and temperature 350 degrees Celsius is given. Now we will refer here the pressure table. So saturated water and steam pressure table at 15 bar, what is the corresponding temperature? So here in the first column pressure is given in bar, 15 bar, and in the second column temperature is given, it is 198.3. So this given temperature is more than this 198.3. So we can say that this temperature is for the superheated steam. So here we can say that this is the temperature, that is T superheated is equal to 350 degrees Celsius. So here T superheated is 350 degrees Celsius and temperature at corresponding pressure, that is P1 is equal to P2, that is here temperature T1 is equal to T2, which is equal to, it is given 198.3. So without any word is used here, the superheated, we have to find out whether the temperature of steam is superheated steam or not from the steam table. Now we will move for the next. So we have to find out what is the Rankine efficiency. So Rankine efficiency, that is neta. Neta is equal to H2 minus H3 divided by H2 minus HF3. Now again we have to find out what is this H2, H3 and HF3. So for that we will again find out the enthalpies at the different points. So here the enthalpy at point 2, that is nothing but the enthalpy of superheated steam. So enthalpy of superheated steam, that is H superheated, that we have to find out. So how to find out this enthalpy? So if we observe, this pressure at point 2 is given as well as temperature is also given. So in the steam table, here is the table, that is the specific enthalpy of superheated steam is given. This is the table. So for this table we have to take the 15 bar pressure and temperature is 350 degrees Celsius. So here for the 15 bar pressure and temperature 350 degrees Celsius, the value is 3148.7. 3148.7. And what is the unit? That is kilojoule per kilogram. So this, from the superheated table we can find out what is the enthalpy of superheated steam as well as entropy of superheated steam. So we will find out the entropy also. So in the next table is the specific entropy of superheated steam. So for 15 bar it is for 350 degrees Celsius. So here on the vertical column pressure is given and in the horizontal row here temperature is given. So here is 350 and here is 15. So it is 7.104. So S superheated is equal to 7.104 kilojoule per kilogram Kelvin. So this entropy is also calculated and enthalpy is also getting calculated. Now we have to find out H3, that is the enthalpy at point 3. Now if we observe this point 3, then H3 is equal to, this is the wet steam, that is the condition of working substance is wet steam because it is in between saturated liquid line and saturated vapor line. So how to find out this H3? So H3 is HF3 plus X3 HFG3. Now we have to find out this dryness fraction X3. So how to find out? Now if we observe this point 2 and point 3, point 2 that is 2 superheated, that is the entropy of this superheated steam at point 2 is equal to entropy at point 3, that is S3. So from the diagram we can write here S superheated is equal to S3, that is entropy at point 3. Now how we can find out this S3? So this is the wet steam. So again we will write which is equal to SF3 plus X3 SFG3. Now what is SF3? So we have to find out the entropy at point 3 corresponding to given pressure at point 3, that is P3. So P3 is 0.06 bar. So again we will refer here the pressure table. So at 0.06 bar, so here 0.06 bar we have to take the value of entropy, that is SF and SFG. So I will write here SF is given 0.521 plus X3 into SFG, it is 7.810. And what is the value of S superheated? So we have to take this value from superheated steam table, that is the different table is given at the end of this steam table book. So it is 7.104. So here is only one unknown term, that is X3, and we can calculate this. To calculate X3 we have to take 7.104 minus 0.521 divided by 7.810, which is equal to 0.84. Now with the help of this X3 we can find out this H3. So H3, that is HF3 plus X3 HFG3. So at point 3 we will find out the value of HF3 and HFG3. So for this pressure P3 is equal to 0.06 bar. So again we will refer here the pressure table, and HF and HFG value are given. So we will take here 151.5 plus X3, that is 0.84 multiplied by 2416, and which is equal to 2180.94. So we will put all the values. So instead of H2, because this is the case of the superheated steam, we have to use here H superheated. So H superheated, that is 3148.7 minus H3 2180.94 divided by H superheated 3148.7 minus HF3. So HF3 is 151.5. So when we calculate this, we will get the answer 0.322. But here is the efficiency, that is the Rankine efficiency. So we will multiply here with 100 and the answer is 32.2%.